Hi everyone, I'm going to solve 3.7 example 4. This example is a bit more complicated than the previous examples, and it's a very important example. So make sure you go over it, make sure you totally understand this in case it's going to be a long answer question in your exam. The circuit shown has been connected for a long time. The capacitance is 1 microfarad. The voltage of the battery is given. It is 10 volt. And here we have 4 resistors. We could label them as R1, R2, R3, and R4. So again, remembering that the circuit has been running for a long time. That's the key. What is the voltage across the capacitor? They want the voltage across the capacitor. So when the circuit runs for a long time, then the capacitor is full, because what happens is that when you kind of like start running the circuit, the capacitor will charge up. The battery will send current through the circuit, and the current will move and will sit as charges on the plates of the capacitor. After a long time, the capacitor becomes full, and it tells the battery that I'm full, please do not send any charge. So when that happens, now look, the current that is coming out of the battery, it is I, and it will branch out to two currents. So I can label them as I1 and I2. So let me write I2 in here. So this is R2 and I have an I2. So it will branch out to I1 and I2. If the current was still running through the capacitor to the capacitor, then you will have an I3 here. But because the capacitor is full, the capacitor does not accept any more charges. So after a long time, I3 becomes 0. So we won't have any I3 anymore. Now, in order to find the voltage across the capacitor, we're going to need to find I1 and I2. So what we're going to do, we're going to use loop rules. I am going to take one loop as loop A. So I am going to go here, and then go here, and then I'm going to go literally clockwise and complete my loop. Yeah, so I'm going to use loop A, represent A, loop A. If I write the equation for loop A, well, you could start from the battery. You could start, let's say, from here, and then move clockwise. So if I move clockwise, I reached the negative pole of the battery first. So I reached the negative pole of the battery first, therefore I'm going to put plus 10 in here. Then keep moving, and now remember, you're picking loop A. Then I move here, then I will get to R2. R2 is 4 ohms, then I'm going to write minus 4I2. And keep going. So this I2 will also go through R4 as well, because I3 is 0. Yeah, if I3 is 0, I2 will not be broken into two parts, because the capacitor does not accept any charge. So the same current I2 will go through both R2 and R4. Therefore, I can write once I reach R4, I can write minus 1, R4 is 1 ohm, minus 1 I2, then I keep going, keep moving, and I get to that blue point again. Set it equal to 0. Now, this equation is quite simple. Collect the like terms, minus 5 I2 equals 0. Isolate for I2. I2 is equal to 2 amp. Now I have found I2, then I want to find I1. So the loop that you're going to pick, it's going to be this outer loop. and I'm gonna call it loop B. So for loop B, I start from the blue point again. You could start from the blue point again, and then you would reach the negative pole of the battery first. So I'm going to use plus 10, then move, 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 but take the branch that has I1 in it. Yeah, that's the outer loop. So then you would reach R1 in the direction of the current. I'm going to use minus 2I1. Keep moving, then you would reach R3. In the direction of the current, I write minus 8I1. Still, this is I1 because I1 will not get branched out because I3 is 0. I1 is still will go through IR3. Therefore, that's why I have minus 8I1. That is equal to 0. Now collect the like terms. Minus 2 minus 8 gives me minus a 10I1 equal to 0. If you isolate this equation for I1, you will derive 1 amp. Good. So I have found I1 and I2, but that is not the answer to part A. But these two are going to help me to find the, the potential across the capacitor. So the way that I do it, I am going to draw another loop. I'm going to create another loop. The loop that I will pick, you could do your loop like this. Now you could just go like this. So the loop is this inner loop. You can call it loop D. And for loop D, you could write, so you're going to use the loop rule again. So you could write minus R2I2. R2 is 4 ohm, so minus 4I2. So I start from this point, this blue point, and then I move in the direction of I2 and I will reach resistance R2. Once I do that, because I'm moving in the direction of I2, I have to write minus 4I2. Then plus, I would reach so if I move this way, then I will reach the capacitor. So you could just write plus the voltage of the capacitor. And then keep going, then you reach R1. You reach R1, but you're moving in the opposite direction of the current I1. So I have to use plus 2I1 equals 0. Now, knowing I2, if I sub in 2 for I2, and knowing I1, which is 1, then you can find the voltage across the capacitor, and that would be equal to 6 volt. So using 3 loops, I have been able to find the voltage across the capacitor. So that is part A. Part B, if the battery is disconnected, how long does it take the capacitor to discharge to 1/10 of its initial voltage? So now I am going to take the battery completely off the circuit. So let me draw the circuit one more time. So once this happens, once the battery is off, the capacitor starts discharging. So I have R1, which is 2 ohm. I have R2 here, which is 4 ohm. I have R3, I call that R3, which is 8 ohm. And R4, which is 1 ohm. So in order to figure out how long does it take for the capacitor to discharge and you're provided with the voltage, the equation that you need to use is V equals V0 e to the minus t over R times the C. We have the capacitance in here. We also have the initial voltage, which is literally the voltage of the battery, or literally you could say, look, it's V divided by V0 is provided, it's 1/10. Now what you could do, you can find the time here. However, I need to find R. So you're thinking about what R value we are going to put in this equation. That R value should be always the equivalent resistor. That means that I'm going to need to combine my resistors. Looking at this part, you could see that R1 and R2 are in series because only one end of R1 is connected to one end of R2. That's one reason. The other reason is that now the battery is out of the circuit. The current that is going through R1 will go through R2 as well. So I'm going to combine R1 and R2, and I have a R12, which is R1 plus R2, and that gives me 6 ohm. Similarly, R3 and R4 are in series, so I'm going to combine them. R3 plus R4 equals 8 plus 1, that gives me 9 ohm. Now, if I draw my circuit again, this part of the circuit again, let me show you in here. So I have a R12 and I have a R34. You see that R12 and R34 are in parallel because the voltage across the two is the same. One end of R2 is connected to the other end. This end of R12 is connected to the other end of R34. So they are in parallel. They have the same voltage. Now I need to combine R12 with R34. Because they are parallel, I have to use this formula. So R equivalent equal, this is the shortcut formula that I like to use. So it's R12 times R34 divided by R12 plus R34 equals 6 times a 9 over 6 plus 9. That will give me 3.6 ohm. Now, you're provided with V divided by V0, or you can call it V max. They're the same thing. So V divided by V0 equals minus a T over R times a C. V divided by V0, it's 1 over 10 equals e to the minus a T divided by R, which is 3.6. And the capacitance is provided in here. It's 1 microfarad, so I have to multiply it by 1 times 10 to the minus 6. Now, take the ln of both sides to bring the T down and then isolate for T. If you do that, you will get 8.3 times 10 to the minus 6 second. And that would be the time for the capacitor to discharge, but also its voltage will be 1/10 of its maximum voltage.